All right, in this section, we're going to look at exponential growth and decay models. So we're going to take a look at some examples. Using this formula, f of t equals to a sub 0 times e to the k times t. Whereas we have here identify in the formula what t represents, k, a sub 0. Well, t represents the time, the value at time t. A sub 0 represents the value at the start. So we'll look at some questions where the start is given. And then we have our natural base e raised to the k times t power. And k represents the rate of growth or rate of decay, but it depends on if the growth is if k is positive or if k is negative. So when k is greater than 0, it's the rate of growth. If k is less than 0, we're looking at the rate of decay. So you have here two models, exponential growth. Here again, when k is greater than 0, the function is increasing. And then we have an exponential model where it represents exponential decay, where the function is decreasing, and that's when k is less than 0. So we're going to take a look at some questions that we will be using the exponential growth or decay equation. So let's take a look at the first example. We have here the exponential model. A is equal to 224.2 times e to the 0.02 times t describes the population A of a country in millions t years after 2003. Use the model to determine the population of the country in 2003. So the model for this example, A is equal to 224.2 times e to the 0.02 times t. Well, it says t represent the years, and we want to find out, we want to determine the population of the country in 2003. Well, since that we don't know what the population is, or if it's starting in, in t years, we're starting at 0. So what we're going to do is substitute 0 in for t, and we have 224.2 times e to the 0.02 times 0. And we know anytime we multiply by 0 is going to give us 0. So the exponent, we have 224.2 times e to the 0 power. And recall that e to the 0 power is 1. So now we have 224.2 times 1. So the population in 2003 is 224.2 million. That would be our solution to the formula that's given.